This is the main experimental setup here. You've got your video screen there, keyboard for the computer here, and the high-quality sound system here, which includes a graphic equalizer and a cassette player, and then there's the compact disc player here. This is much bigger, of course, than you'd have in a normal car setup. It's purely experimental, and the whole thing would be miniaturized a great deal and set in the dash and so on in a car of the future. But for the moment, let's just see how it all works.
Welcome to the carrying system. Insert
right, well, that asks me to insert the disc, so I take one of the discs from a little file here, which also contains music discs as well as the information disc in a special holder, and you can just pop that into the slot here, and it will then give us instructions on what to do. But only after some information from the driver, punched in on the computer keyboard, saying, we want to reach the Philips headquarters building. Well, now that we've got the relevant information into the computer, that's our start point and our final destination, which is really all that the computer requires, all we've got to do is to press this button in the top left-hand corner, which says go, and in a few seconds the map will appear and we'll be on our way. There we see the map, and that's our position at the cross street now.
Straight ahead.
And we're heading up this
Straight ahead.
Road here to the main road here, and you'll see that the dot will move. It's moved now.
Take first turning left. Take first turning left.
Philips have called it the Karen system for car information and navigation, and it works by using an electronic compass mounted on the roof combined with the car's odometer, which keeps an extremely accurate count of the number of revolutions of the wheels, so that it knows exactly how much distance has been covered in what direction. Coupled with that is an equally accurate map of the particular city or town you're traveling through, in this case the city of Eindhoven, which has been transferred into the computer's memory. It's a bit like an electronic co-pilot. If you have to turn off a main road, the computer will tell you.
Take first exit at roundabouts.
The compact disc holds all of the road and street name information for the whole of Holland. Every street name, every hotel, every public facility. In fact, everything that could be of use to a driver traveling through Europe. When you cross a border, you just put in the relevant disc for France, Belgium, Germany, or whatever. Although the dead reckoning system using the compass and odometer works well, future plans call for the Karen system to be tied into the American Global Satellite Positioning System known as Navstar, which will have 18 satellites in orbit, 4 of which will always be visible from any point on Earth. When that is operational by the end of the decade, the car's position will always be known with an accuracy of less than 3 meters, about 10 feet. One of the really interesting aspects of the system is that once the local area map is in the computer's memory, you don't have to use the disk anymore. So you can put that back into the file, take another one, a music one, and play some music. And what happens is that the system will override the music or the radio, if you happen to be listening to that, to give you relevant information whenever it's needed.
We have arrived.
Using a spring action bar, but there are some major differences. To set it, you don't have to lose a finger. You just pull this cord here. Now enter the mouse. The trap snaps, and the last poor rodent. Because it's covered, all you see of the deceased is its tail. And to dispose of the body, you open the bin, pull the string, and out she drops. So you don't have to rebait the trap. All you do is pour some dripping or food essence through this little hole here in the bottom. And as you can see in this cutaway version, this filter absorbs the juice and keeps the trap baited for several weeks. According to the saying, build a better mousetrap and the world will beat a path to your door. Well, with over 1 billion mousetraps sold around the world each year, if this mousetrap takes off, they may need a freeway. Coming up next, keeping tabs on heavy transport.
Large or small, presents problems for both owners and drivers. Owners see their expensive investment roll out of sight and must put their faith in the driver being careful. If something does go wrong, it's a natural assumption that the driver is at fault, when that's not always the case. Now, a new system called Fleet Master uses a computer in much the same way as the black box flight recorder is used in an aircraft to monitor a vehicle's vital signs, such as revs per minute, speed and oil pressure. Not only does it show how a truck has been driven, it can help a driver develop better driving strategies that save fuel and preserve the engine. In the cab of the truck, the driver's console displays the truck speed to 1% accuracy. Drivers can enter the amount of fuel they have just put in the truck and any reasons for stopping, for example for a breakdown or roadworks. This information, and indeed all the information about the truck, is recorded in the data acquisition unit.
Had a good trip?
The transfer unit records all the information from the truck and can then dump it onto a personal computer or a printer. And for large operators, a debriefing unit can be installed at the petrol bowser so the drivers can download information whenever they fill up. Another feature is the crash report, a second-by-second account of the truck's speed before an accident, which can be used to support a driver's version of events. By helping drivers learn good driving habits, such as avoiding over-revving the engine, and by encouraging them to adhere to company speed limits, the Fleet Master should aid in keeping maintenance and fuel costs down, and in promoting greater road safety.
Given to thinking that all aluminium is as weak as this can, pure aluminium by itself is a very weak metal, and as this simple demonstration has shown, can't withstand much strength at all. But combined with certain alloys, even aluminium can be strong. So strong, in fact, that it could ride rings around steel. Strength doesn't necessarily mean weight, though. While the world's best cyclists have all moved over to the expensive carbon fibre bikes, the committed amateur is still slaving on steel. But weighing in with a frame of just 1.3 kilograms, or 3 pounds, is Peugeot's new baby, the all-aluminium bike. And here to show us its style is Jean-François Guiberel, Peugeot's cycle leader. Okay, Jean-François. In France each year, 2 million bicycles are bought, and at least 2 months of each year are dedicated to France's healthiest national obsession, riding a bike as fast as possible around the entire country. The Tour de France until now has virtually been an all-steel or carbon fibre event. But when you're pedalling a machine up a 20-degree slope, every ounce of extra weight you're moving uses precious energy. Bicycle manufacturers have been wanting to build aluminium bikes for years, but until now the problem has been joining the bits together. The average bicycle frame has 8 rods, and in a steel bike, those rods are welded together. Welding, of course, requires a lot of heat, and the softer aluminium metal, when welded, simply warps or melts altogether. So what Peugeot have come up with is a pin and sleeve joint to connect all of those rods, so the entire frame is constructed without one weld. And the advantages? Well, it's corrosion resistant, lightweight, extra strength, and a much lower price tag for a high-performance machine. There's one other advantage too. If you ever tire of riding your bike, you can always recycle it.
Well, fellow high-tech highwaymen, be warned. Office equipment will no longer lie there for the taking after hours, nor will home video recorders lie defenseless while their owners are out. What I failed to notice about this tempting array of computers was the gripping new device beneath them, called the anchor pad. It's been developed to combat increasing computer theft. Now, the anchor pad literally glues the equipment to the workbench with a total force of 3,000 kilograms. It's suited to all types of machines, from your own video recorder to a calculator or even a lab microscope. Now, this device will solve the security problem in homes, offices, laboratories and schools where these machines come under frequent attack. Now, this is a model of the anchor pad using clear perspex to illustrate both attachment surfaces. These adapter feet, these black things here, glue to your machine and lock into this metal plate. We've represented the plate with perspex here. Underneath is the adhesive pad, which sticks to the workbench itself. Now, I release the mechanism by just turning this key here and removing these two long steel rods. We've taken one out. There goes the second one. That's the special extractor tool. Now, underneath is the base plate. I can now move the machine, whatever it is, on top of this particular plate should I wish to move offices. The adhesive pad, meanwhile, can be removed in 20 minutes using infrared heat without damaging the bench surface itself. Now, there are two extra features of this system which defy sophisticated lock-picking devices or people with screwdrivers. However, to reveal these really would be telling. I mean, they wouldn't even tell me. To be perfectly frank, there's no point in sticking around. I'm off downstairs.
But mainly they operate in a known environment. A lot of care is taken to make sure a robot's tasks and tools are pretty much where they expect them to be. Because even at this stage of development, they're easily confused. Robot vision, teaching robots to see and recognize predetermined shapes, has made exciting advances. But robot vision in the commercial arena is restricted by robot memory. These robots, for example, although they can recognize dozens of pre-programmed shapes, would not recognize a piano or a Picasso in your living room. The results of making them mobile would be disastrous. Other robot systems like this, the Denning mobile robot, have hosts of sensors on board feeding back information on their environment. Designed ultimately to patrol prisons to alert guards of security breaches, this unit uses ultrasonics, infrared, television, and bewildering mathematical algorithms to sense the geometry of their environment. But give this robot a set of stairs to negotiate, and it would blow its circuits with confusion and frustration. But not this eerie-looking contraption. Stairs and such obstacles are its stock in trade. Odex 2 looks like a cross between a tarantula and a black hat box, but what it's doing requires some very elegant computer programming. It can approach an unknown set of stairs and negotiate them. The TV camera on top provides the geometry of the situation to 7 onboard computers. A very complex vertical reference system allows the unit to negotiate steep inclines without it toppling over. The demonstration of the unit's agility and strength has prompted a number of large US organisations to provide additional funding to the Californian-based company Odetics Incorporated to tailor the unit for specific applications. The Defence Department is interested because they foresee such an artificial intelligence machine on the battlefield, taking the place of or backing up foot soldiers. There are a multitude of chores for these computerized GIs of the future. Prowl suspected minefields, stalk tanks, fire rockets, perhaps even act as fearless medics to evacuate casualties under fire. One vocation Odex 2 will miss out on is being a commando. There's no way this contraption could sneak up on you. The powerful electric motors, driving the hydraulics and the linkages for the legs, create quite a racket. And its battery life would have to be extended beyond the 1 hour of constant running that it's presently capable of if it's to be truly autonomous in the field. But the Odex is still a test bed, and it's likely that platoons of these functionoids may be placed in a semi-static position, awaiting an oncoming force. And within an hour, they could do quite a deal of damage. The key issue in the minds of defence strategists is demographics. The World War II baby boom that previously provided the young men and women who could be conscripted into the military services is over. The West has an ageing population, so expendable robots make a lot of sense.
In addition, we are interested in what is called force multiplication. The Soviet Union and the Warsaw Pact and conventional forces outnumber us, and quite strongly. They have 4 to 5 tanks for every one we have. They have 3 to 4 artillery pieces for every one we have. They have more soldiers than we have. So we do not seek to quantitatively match them. That's too expensive. Furthermore, we don't have the manpower to do it. So instead, we would rather gain a qualitative edge, and robotic technology can help us do that. Furthermore, it can even more so help us do it with reduced manpower by augmenting the force effectiveness of our existing manpower, and even in certain cases taking the place of men or humans in these tasks at this time.
I suppose that's particularly relevant when it comes to tanks. They're very expensive, very heavy, and really specifically designed to protect the human occupants.
A main battle tank today, with all of its equipment, its armor, its life support systems, its sensors for humans, is very expensive. It's on the order of $3 million a copy. And if you can instead replace one or more or all of those human crew members, you can dramatically reduce the size of the vehicle, lessen its complexity and cost, give it a much higher survivable factor in that it's no longer as big, it's a harder target to find and hit. And furthermore, you're extending the use of what manpower you have, because now you can have a case of one human in a protected remote control van, perhaps controlling a half a dozen of these robotic devices.
There are also a host of peacetime duties planned for these robots. Odetics Incorporated have been given a multi-million-dollar contract to develop a remote-controlled nuclear plant maintenance robot, an artificial intelligence device that could move freely about inside cramped corridors with special tools, oblivious of how many ronchins it soaks up. And perhaps one day soon, a robot specially protected and equipped might be seen scrambling into burning buildings, searching for survivors, and fighting the searing centre of the flames.
Doctor's disposal, and highly trained pathologists can tell anything from how well your liver is functioning to how healthy your diet is. They can even tell you when you last had an alcoholic drink. The problem is that the results often take over a day to get back, and the machines the pathologists use can cost upwards of $100,000. Well, these small Kodak slides are virtually complete pathology laboratories in themselves, and they can give blood analysis results within minutes. A drop of blood placed onto a slide slowly filters its way through 4 layers of chemicals which have been specifically designed to make the blood change colour according to the chemicals dissolved in it. The process uses only a tiny drop of blood instead of the test tube full required by conventional pathology. The blood is first spun at 6,000 revolutions a minute in a centrifuge. The rapid spinning forces all the blood cells to the end of the tube, and after a few minutes, a precise amount of this clear plasma can be sucked into an automatic pipette. From there, the blood is placed onto the slide in this way. And in order to keep the temperature constant, the reactions all take place inside this analyzer. So all we do now is wait a few minutes. All the chemical reactions have now taken place within the slide, so to analyze any changes in the chemicals, the machine shines a colored fiber optic light just here onto the slide. It measures any reflections, works out what color the slide has changed to, and it prints out the results. Well, according to this, I have 4.5 millimoles per litre of fat-like cholesterol in my blood. But I'm happy to say that that's normal. The Ectochem isn't nearly sophisticated enough to replace pathologists. Far from it. Pathologists themselves will use the machines. But since the Ectochem is inexpensive enough for doctors to have in their surgery, it can certainly save time on routine blood tests. And for doctors in the country who may be hundreds of kilometres from the nearest pathology lab, that time could save lives.
Coming up, cameras that catch what the eye can't see.
Lights, camera, action. The film business is all the same. The difference here is the star. It's an archer fish. The director and the cameraman on this film are trying to photograph the fish capturing its prey. All of the action takes place in less than 1 second, and if you blink, you miss it. But they won't miss because the camera photographs 100 frames per second. This is what the film will look like. You can see every movement as the chameleon catches its prey. The films created here are of a more scientific caliber than their Hollywood counterparts. Without them, we would be unable to see some of the astounding sights of this universe. Take, for instance, the airy gracefulness of a bird in flight. Institute has over 6,000 films. Look at all of these catalogs. There's biology, technical films, anthropology, physics and chemistry, medicine, and psychology. Let's look at some of the titles. There's, let's see, The Feeding Habits of a Leech. And here, The Development of a Newt Germ. And on this page, let's see, The Ejection of Seeds from a Squirting Cucumber. That doesn't sound interesting to you? But it is, especially when you look at it through the lens of their cameras. The scientific film records unknown processes for the first time. It helps researchers and students in the classroom to understand the process of one movement to another. By photographing the metals and alloys that we rely on, scientists can study how to improve them. This film of metal being welded was photographed with a camera that shoots 2 million frames per second. This is what's called cinemicrography. This 35mm time-lapse camera is attached to a microscope, and it can take pictures at 1 frame per hour or 150 frames per second. Right now, it's taking a picture every 4 minutes. They're trying to record the eye growth of a moth during metamorphosis. An example of cinemicrography is the enchanting dance of the formation of sporophores. The Göttingen Film Institute will continue its search for innovative methods of photography in its ongoing effort to uncover the secrets of life on this planet.
places yet visited by humans. The low gravity makes life tricky, and the near vacuum makes it lethal. But above all, it's the temperature which gave NASA engineers and American astronauts the most problems. Out in the direct sunlight, where there's virtually nothing between you and the sun, the surface temperature soars to over 100 degrees Celsius, while in the shade, just a few meters away, the temperature drops to around minus 200 degrees Celsius. That sort of temperature range makes designing protective clothes a formidable task. And one of the materials the engineers came up with, called SP27, looks as though it might have uses back here on Earth. Well, it's certainly not as cold here inside this industrial freezer as it would be on the dark side of the moon, but it's still pretty nippy, about 15 degrees Fahrenheit, which is about minus 10 degrees Celsius. This clothing that I'm wearing is only a couple of millimeters thick, which is less than half the thickness of a conventional down jacket, and of course a good deal lighter, and yet I'm just as warm. Now, you've probably guessed that the material is SP27, and the reason it's able to keep me so warm is that it has a microscopically thin layer of aluminium that's sprayed between the insulating fibers of the material. Now, good quality outdoor clothing protects your body from losing heat through conduction, convection, and evaporation by trapping a layer of still air between yourself and the cold. Well, unfortunately, there's another way for the cold air to strip body heat from you, and that's through radiation. Out in the cold, your body just acts like a furnace, radiating heat outwards. With this sort of clothing, the aluminium layer simply reflects all of that radiated heat back into the body. When looked at through a thermal imaging camera, which sees heat rather than light, the effectiveness of the suit can really be seen. Barely any heat is being transmitted through the material. In fact, the outside of the material is only a few degrees above the air temperature, which shows that all of the heat is staying where I need it most, next to my body. And if you compare that to the heat coming through the conventional clothes that are being worn by a member of the camera crew here, you'll see why I'm so warm. The material has been tested by explorers in the most severe conditions on Earth. So Ranulph Fiennes used an SP27 suit in the Antarctic, where temperatures as low as minus 60 degrees Celsius could freeze exposed skin in just 25 seconds. Well, SP27 will soon be on the market in the form of sleeping bags and jackets. But ironically, although it's a good deal lighter, this high-tech material is still not quite as good an insulator against the cold as an Eskimo's traditional fur.
This is a fishy story from England. Most of these fish will end up on the dinner table, but some of them, in the form of fish oil, will end up as building blocks. The oil is added to an isocyanate chemical and stirred. And within a few seconds, voila, polyurethane foam. You don't have to use fish oil, but it's cheap. And here in Durham, in the north of England, they're even building houses out of it.
That's right, I said fish. This house was almost entirely built with polyurethane foam building blocks, the main constituent of which is something that you use to stop the rust in your car, fish oil. Those polyurethane foam blocks have excellent sound and heat insulation properties, and I'm told that a husband and wife could build a house like this in as little as 1 month.
The foam's injected into a steel mould under pressure and comes out as building blocks of a uniform size, 2 feet or 61 centimetres square.
Cuts, Jeff. Light enough, isn't it?
It is.
You've got that's the standard building block then, is it?
Standard building block.
And you've got the that part exposed there to show how you can put your electrical conduit in as well.
That's correct. It shows the configuration of the electrical work.
Well, it's extraordinarily light. How light is it, in fact?
It's 3.8 kilos.
So what sort of difference, say, a standard, one, two-bedroomed house compared with a brick-built house, what's the difference in weight all up?
Half as heavy.
Yeah.
As a standard house.
When you're building a house, the blocks fit together using a timber insert, and then they're cladded with wire mesh. The electrical power points are added in the factory.
The insulation properties of these blocks is the best in the world. You just can't get any better. There's no point. Your walls would have to be 6 foot thick before you'd really get any extra benefit.
It's not likely that fish foam houses will start up staging the humble semi-detached. Not just yet. But in warmer third world countries, foam houses may prove to be more of an economic reality and less of a fishy tale.